Welcome to this deep dive into the compressed inverted magnetic energy source, or CIMES, a patented innovation that's sparking conversations about the future of energy. I'm Your Name or Factsphere, and today, we're tackling a common misconception head-on. CIMES is not a perpetual motion machine or some over-unity gadget that defies the laws of physics. Instead, it's a groundbreaking design rooted in Newton's laws, electromagnetism, and thermodynamics. It requires external inputs, converts finite energy stores, and even needs regular maintenance, just like any real-world mechanical system. By the end of this video, you'll see how CIMES harnesses proven science to generate rotational torque efficiently, without violating any fundamental principles. Let's break it down technically. First, let's explore the core design of CIMES as detailed in U.S. Patent 11-199-400B2. Invented by Dan Buck, this system features a stationary stator, a funnel-shaped housing made of non-magnetic materials like aluminum, lined with permanent rare earth magnets, all oriented with the same pole, say, north, facing inward toward a central axis. Nested inside is the rotor, a frustum cone-shaped component with outward-facing magnets of the same pole. These magnets are arranged radially and angled. Perpendicular to their surfaces or tangentially to the circumference, to direct repulsive forces azimuthally in the phi direction of spherical coordinates. The magic, or rather the physics, happens through axial compression. A compression plate, connected via a flange and ball bearings, pushes the rotor closer to the stator along their shared axis, reducing the gap between opposing magnet pairs. According to the inverse square law of magnetism, the repulsive force F between two magnets scales as F1d2, where d is the distance. So, having the gap quadruples the force, amplifying the net unbalanced repulsion that drives rotation. But here's where we prove it's not perpetual. This compression isn't free or self-sustaining. It requires external energy input, whether manual, via levers and ratchets, mechanical through threaded screws, or electromechanical with motors. Without this ongoing or adjustable force to counteract the natural decompression from repulsion, the system would separate and stop. Think of it like compressing a spring. You're storing potential energy, but it's finite and must be replenished. Diving deeper into the mechanics, torque generation follows Newton's third law. Every action has an equal and opposite reaction. When like poles repel, north to north for instance, the force on the rotor magnet pushes it rotationally, say counterclockwise, while the stator absorbs the reaction without moving. The patent specifies uneven magnet spacing to minimize counter-repulsive drag during brief misalignments, ensuring only a fraction of pairs oppose rotation at any time. This is smoothed by a flywheel attached to the shaft, which stores angular momentum, L, Shermander, IO, where I is the moment of inertia from the flywheel's radial mass distribution, and O is angular velocity. The tip of the rotor and the stator's vertex, each house, an additional magnet pair, aligned axially with same poles facing, creating an upward repulsive force that reduces friction against gravity. A clever application of magnetic levitation principles. Ball bearings further minimize losses, but they're not perfect. Real-world efficiency hovers below 100% due to eddy currents, hysteresis in the magnets, and residual drag. Critically, CIMES converts stored magnetic potential energy, inputted via compression, into kinetic rotational energy, not creating it from nothing. The energy balance equation is straightforward. Input work, W compression, Joubers F compression XDD, raises the system's potential, U magnetic secumons mons M0 secumons 4P, M1 secumons M2 1D, which then dissipates as output torque work minus losses. No net energy gain. It's a transducer, like a hydroelectric dam converting gravitational potential to electricity, but here it's magnetic. Now, let's address thermodynamics head-on. Perpetual motion machines of the first kind claim to create energy, violating conservation, first law. Second kind ones extract work without a heat gradient, defying entropy, second law. CIMES does neither. The inventor explicitly notes that the system's action-reaction pairs comply with conservation. Magnetic fields are conservative, meaning the network in a closed path is zero without external input. The inverted aspect, repulsion under compression, exploits field gradients efficiently, but output is always less than or equal to input after accounting for inefficiencies. For example, in prototypes, startup requires an initial spin from an external motor or crank to overcome static friction, building momentum in the flywheel. Without this, no rotation, and under load, say, coupled to a generator for EV recharging or home power, the system draws down its finite potential faster, necessitating recompression. This is why CIMES aligns with complex physics like electromagnetism, Maxwell's equations for field interactions, and rotational dynamics, Euler's equations for rigid body motion. One more nail in the perpetual motion coffin: maintenance. Like any machine, CIMES needs occasional upkeep. Bearings wear over time, magnets can demagnetize, though rare earth ones last 100+ years, and compression mechanisms require lubrication or adjustment. The patent mentions vacuum epoxy coatings for harsh environments like space, but real operation in dusty or high-temp settings demands servicing, proof it's a practical device, not an impossible eternal spinner. This unique design, with its funnel frustum geometry, tangential magnet angles, and adjustable compression, is truly novel, as validated by the USPTO for non-obviousness. It follows Newton's laws at every step. F engra ma for linear forces, extended to torque Taumjon baz, IA for rotation. In conclusion, CIMES is a testament to innovative engineering grounded in solid science, not pseudoscience. It harnesses magnetic repulsion through clever mechanics, requires real inputs, respects thermodynamic limits, and promises efficient energy conversion for applications like electric vehicles and space exploration. If you're inspired, check out the full patent, prototype one yourself, or join the conversation on sustainable tech. Thanks for watching. Subscribe for more fact-based deep dives, and remember, true innovation spins within the laws of physics. See you next time.